Do you remember what kind of tissue blood is? This is a phenomenal final exam question. What kind of tissue is blood? Blood is a connective tissue. And hopefully you're like, boom, I know what connective tissues are. Connective tissues are cells within a matrix of ground substance and fibers. And that's what all connective tissues are. And you might be thinking, but we have been looking at irregular connective tissue and dense, irregular connective tissue, and how can fluid be a connective tissue? But remember that connective tissue is highly diverse, and fluid connective tissue is a really interesting variation on the theme. So let's look at, we have two main components of blood, and that is we have plasma, which is a fluid component. And then we also have cellular elements. And the term is cellular elements because, as you'll see, someone who's included in the cellular element club isn't actually a full cell. So they're kind of, well, we'll talk about that in a second. You have about total 5 liters. 5 liters of blood, which is about 10.5 pints. I have a visual of a pint of Ben & Jerry's, and so I can imagine my 10.5 pints of Ben & Jerry's flowing through my bloodstream. Holy cow, that would be a lot of ice cream to eat. Some days it feels like I could do that. Your plasma, you've got about 3 liters. So what is that, like 6 plus pints is plasma, which is this fluid substance. Your cellular elements, obviously, you end up with 2 liters. That's what's left over. So if you were to separate out your blood into the cells and the plasma, which is the fluid part, then you would see that you have more plasma than cells. And we're actually going to show you a visual of doing just that. Let's talk about our plasma first. 92% of your plasma is water. 92% water. And that's how we ended up with it being fluid. The plasma is actually your ground substance. Your plasma has stuff in it, which are considered our fibers. About 7% of your plasma is proteins. And so you can imagine, okay, so here's my plasma, and I'm showing you that there's waves in there because it's fluid. You go surfing in there on your blood. And now I'm going to show you the proteins because we have all different flavors of proteins. There are proteins called antibodies. They are an important part of blood, and they may actually make up a bunch of the blood. Antibodies are involved in your immune system, and I'm just going to draw a few of them in here. Now, the plasma proteins are important players when it comes to how blood functions, to some of its functions. Clotting is an interesting function, and we have some proteins that are involved in clotting. One of them is called fibrinogen. And so fibrinogen plays a role in clotting. And you can imagine that there's just these little pieces of fibrinogen just floating around in your blood. And then you have other stuff. You have a substance called albumin. It's kind of, it's also a protein, and it's one of the primary proteins that's found in your plasma. The amount of protein in your plasma plays a role in maintaining, keeping the blood, the fluid, the plasma in the vessels and not seeping out into the rest of your tissues, like into your connective tissues surrounding your vessels, where if that happened, you would swell. That'd be a bummer. And then you have, if you add up my numbers here, you will see that no, we didn't quite reach 100%. 1% of the stuff in your blood is just in the other category. And other stuff includes ions. You can have nutrients. Glucose can be in there. Like there's other stuff sprinkled in, like I imagine it, like sand sprinkling in amongst all these other kind of bigger things. Plasma is where our cellular elements float. And the cellular elements, we've got our main dudes. Who are our main dudes? Erythrocytes, also known as red blood cells. I'm going to draw you a picture of a red blood cell because you can't have a picture of blood without red blood cells. And here's the scoop. About 44% of your cellular elements, no, that's not true actually. I'm going to erase that because the 44% is about how much red blood cells there are in your total blood volume. So we'll talk about that one in a second. But red blood cells are wholly abundant. In fact, when we do the histology of blood today in lecture, in lab, you will see that when you look in at your scope, like red blood cells everywhere. And so red blood cells are extremely abundant. These guys are responsible for gas exchange. So we know red blood cells as carrying oxygen. They also carry carbon dioxide, but they're carrying them back and forth to the blood. To the lungs, so that we can have gas exchange in the lungs. We've got red blood cells. We also have white blood cells, and these guys are called leukocytes. Leukocytes. So those are white blood cells. And leukocytes, we're going to talk about all 5 flavors of leukocytes, but they're all involved in some way in immunity. And the immune system is your protection. Attack the bad guys. They're the army soldiers in the immune system. And the last people on our list are the thrombocytes. Really? Yes. Thrombosis. Thrombosis? Is that a word? A bruise is a thrombosis or a clot. I think it's a clot. Yeah, it is. But a bruise has some, whatever. Guess what thrombocytes are involved in? Clotting. Who are they? They're platelets. And this is where the platelets are why we labeled this as cellular elements and not cells, because platelets, they're pretty fantastic. They're actually broken off cell pieces from these massive cells in your bone marrow called megakaryocytes. So you've got these megakaryocytes hanging out in your bone marrow, and all of your cellular elements from in the blood, well, okay, most of them are born in the bone marrow. And then they go from being in the bone marrow, they squeeze into the bloodstream, and then they go traveling around and doing their thing, whatever they're supposed to do in the blood. But thrombocytes come from megakaryocytes, and they're so huge that they can't squeeze into the blood. So they try, and they're like, the megakaryocyte is trying to squeeze out and go play with everybody because everybody else is in the blood. That looks like fun. And as they're squeezing out, the blood is rushing by so fast that pieces break off. So the megakaryocyte is actually breaking into tiny pieces that float around in the blood, and those are your platelets. And it's awesome. Thank you, platelets, because they play an important role. Look, I'm drawing thrombocytes. I'm trying to show you that they're like broken up little pieces of megakaryocytes. So that's what they're going to do. Okay, you now have everything. Now what we're going to do is let's centrifuge this down. Let's take a tube of blood, shall we? But of course we shall. And let's centrifuge the blood. So if we started out with, you know, this much blood in our test tube, you know, when you centrifuge, you spin it down. And so the heavy, more dense things are going to come to the bottom of the tube, and the less dense things are going to float to the top. And what do you think is the most dense thing in the blood? Well, I'm going to play Pictionary with you if I can find the right. We'll have to go with this. Oh, what color did I use? The erythrocytes are the most abundant item in the blood that is going to centrifuge down the cellular elements. And actually, this is where my 44% came in. Now, they're the most dense. Next in line, I have to pick my color carefully, and this will give you a hint. Okay, let's see what you think of this color. Who is that? That is purple plus blue. That, my white blood cells and my leukocytes, I mean my thrombocytes, centrifuge down to the middle strip, and that they only make up about 1% of the total volume of this blood. And then what's left on top, this is just my plasma. And so the plasma makes up all the rest of it. If you were to spin down the blood, you can actually measure the amount, the number of red blood cells, and that's your hematocrit, and it will tell you your oxygen carrying capacity, which is important. If you don't have enough red blood cells, then you're not going to be able to get enough oxygen to your system. And that the symptoms that you will see are symptoms of anemia. You're tired, you're pale, you're wanting to just rest and sleep all the time because you don't have any energy. It's because you don't have enough oxygen getting to your cells to generate the energy that you need to do what you got to do. For the rest of this lecture, we're going to break down our leukocytes. For having just a measly 1% of all of our blood made up of leukocytes, we're going to spend a good chunk of time talking about each one individually and how they function.